So it's time for Philip. It's time for Dr. Philippe de Ryck. Philip is on a mission. He teaches developers secure coding practices. I've known Philip for several years, and I always thought he was a bit of a bad fit because we're not really a developer conference for various reasons. But when we talked about an eventual appearance with Cyberstorm, we talked, look, I'm also talking about good and bad software development patterns and patterns in software. I think, yeah, now this is a fit here. We're going to talk about supply chain at this conference and good and bad patterns that feeds into supply chain problem. And it is something that I think our audience must be aware of. Many security officers have a background in software development. Penetration testers have a background. But this is something where they return to development, when they look at code, when they read code, and when they try to evaluate code. And that is the core of the talk by Philip. Please welcome Philippe de Ryck on stage at Swiss Cyberstorm.
Thank you for the, I would say, perfect introduction. We didn't practice at all, but Christian actually got it right. I do speak a lot at developer conferences, and I speak to developers in trainings on how to build secure code. And as I've been doing that for several years now, I've come to a conclusion, and that is that we kind of fail at doing that correctly. And this realization comes, I can see that on the faces of developers after, like, at the end of a 2-day training, in the second half of the second day, they're like, holy crap, what the hell is all of this? And there's like guidelines and guidelines on top of guidelines of stuff they have to follow. And that's what we need to do to build secure applications. And if you jump into the mind of developers, it's actually worse, because it's not only about security, because guess what? A couple of months later, they have another training on performance, and that performance trainer has a bunch of guidelines and accessibility and user interface design and so on and so on. And in the end, there's just a hell of a lot of things that developers have to do. And what I don't see happening is I don't see much improvements. And that's what I'm going to talk about here today. Actually, when on a walk this morning, I had to go to the lookout point that Christian suggested, and I updated my title slide with a picture of your beautiful environment. So that's always nice. The title, Patterns and Anti-Patterns, I wouldn't say it's the most exciting title. Actually, when I was working on a talk like this, I've given this before at another conference as a keynote, and I had a better title. My title would be The Road to APPSEC Hell is Paved with Good Intentions. And I kind of like it because it's like very dramatic, and you can work with that. But the more I thought about it, it's the second part, like, sure, the good intentions part is not working out correctly, but I wouldn't say they lead to APPSEC hell, because honestly, I've seen some worse things than trying to build secure software. You have companies that have no idea what they're doing, and sometimes they reach out for training and like, yeah, we just got acquired, and apparently we have to do some security, and we don't really know what we're doing and who knows what, and it's like, yeah, you have a long road ahead of you. And to me, that's APPSEC hell, because if you have no idea where you are, you're probably not in a very good place, and you have some work cut out for you. And that's not what I'm going to talk about here. I'm not going to talk about building up a security program. I'm going to talk about how developers try to do the right thing and still fail. And that is something that worries me and something that we actually should address in practice. By the way, this picture, that's not mine. I took it from somewhere online. I would like to visit it. It's a place that's called the Gate to Hell in Turkmenistan somewhere, and apparently it's a natural gas crater that they mined in the 70s or something, and their best idea when it went wrong was, let's light it on fire, and it's still burning to this day, apparently. So if you ever get the chance to go there, it should be pretty exciting. All right, small word about me. I'm Philippe de Ryck from Belgium. Like Christian said, I work with developers to help them build more secure software, with training, with courses, with consulting, whatever you need. If you want to know more about me, I have a website that explains it all, so go there and read more, and then we can focus on some security things. The first topic, I'm going to talk about 2 topics here as examples, along with takeaways and guidelines. And the first topic are JSON Web Tokens, because it's kind of a gift that keeps on giving. Well, depends on whether you're a pen tester or a developer, whether it's a gift, but it's a topic with some controversy, let's say. And there's definitely something, or a lot of things we should do to address some of the problems we have in that space. In case you're not entirely familiar with JSON Web Tokens, the shortest introduction ever on the topic, it's basically a way to represent data in a secure way. The data is the purple part on this slide, the payload. It's a JSON object, works well with JavaScript applications and so on. And you can represent a set of claims. And we have some metadata in the header, that's the red part. And then at the end, we add a signature. In this case, it's an HMAC, not the best mechanism, but it works well for a single application, creating a token with some information, sending it to a client, getting it back, and then analyzing that information again. So the left part is what we actually call the JSON Web Token. And it's two base64 encoded JSON objects, the red and the purple, with a signature. And that signature is critical, whether it's an HMAC or a public-private key signature, doesn't matter. It's critical to guarantee the integrity of the data. It basically means if I create a token and I sign it with my secret that you probably shouldn't put on a PowerPoint slide, and I send it to you and you give it back to me, I can verify that you did not change that data. I can verify that you did not change the user ID or pretend to be someone else or give yourself additional permissions and so on. Pretty important for security because these things are used everywhere. It's a very easy way to work with. There's plenty of libraries and everybody's using them, even complex ecosystems like OAuth and OpenID Connect. Now you can imagine if the signature validation thing doesn't work out, that's a bit of a problem. If your server says like, yeah, this is good, even though it's not, you have very likely, in the way these are used, you very likely have an authorization problem, which will result in somebody finding a bug bounty vulnerability or breaking in or God knows what. And that's exactly what we see happening in software today. Well, this is from a couple of months ago, an open source project, Apache Pulsar, and they had a vulnerability. And it allowed account takeover in certain configurations, and that certain configuration was if you configured that thing to use a JSON Web Token, you now have a massive problem, because somebody can construct an arbitrary token, feed it to that application, and it will be like, okay, thank you, that's valid, you are now whatever you claim to be, or whoever you claim to be. What happened there? Well, this is from the Daily Swig, a really good source for news, by the way. It's a really awesome blog from Portswigger. And it's very detailed. And they included a link to the GitHub pull request to fix this vulnerability in Apache Pulsar. So naturally, I went there and I looked at it. And here's the vulnerability on the left, the red part, and the fix on the right, the green part. Obvious mistake, right? I mean, honestly, I had to look at this and I was like, I don't know. Sure, I know that the red is bad, but I don't know why. Because both sides are using a signing key and parsing a token, and apparently the red is bad and the green is good. And that piqued my interest. As a trainer, I'm like, interesting. This is a Java library, by the way, for handling JSON Web Tokens. And I was like, why? Why did they make that mistake? Is it that obvious that it's wrong? So I looked, I whipped out an IDE and I built a small code example. And this is what you get when you try to parse a JSON Web Token. You build a parser. Well, you build a parser first. You set a signing key to verify the secret, very important, and then you call parse with autocomplete. And as a developer, this is what you see. 6 parses. I'm a security expert. I know the ins and outs of JSON Web Tokens, and I have no freaking clue what these methods meant. This was the first time I was using this library. I had no idea what was going on. None. I know from the GitHub pull request, that the first one is probably not right, and the third one is supposed to be right, but I don't know why. So, read the documentation, right? I tried to find the Java doc online, nothing in Google, but it's an open source library, this JOT thing. So I looked at the code, and it had Javadoc documentation. And you're not supposed to read all of that because it's not very interesting, but what should jump out at you if you do read it is that there's no mention about the insecurity of the parse function. There's nothing that says like, hey developer, watch the hell out if you do this because this is very, very insecure. It's not. There's nothing there. I actually had to write a code example to verify that the vulnerability indeed existed before I could find out that it was there. And the vulnerability is the ELG-NON vulnerability. If you know about JOT tokens, this is like the worst thing that can ever happen if your server accepts these things. There's a mode of operations in JOT where you can set the signature to none, as in this token is not signed, no verification, whatever. And the library accepts such tokens if you use that parse function, apparently. And that means that an attacker can just construct their own token. They can create whatever they want in the header, in the payload, and attach an empty part at the end. So after the second dot, there's nothing. And the server would be like, yeah, that looks valid to me. Here you go, application. This is user X. And when you change the payload, you become user Y, Z, and so on and so on. That was the bypass vulnerability in Apache Pulsar. So the first takeaway I want to give you here is a very technical one, because I really think it's important. Whenever you handle JSON Web Tokens, include these common pitfalls in your test scenarios. Whenever I work with customers and they have an API handling JSON Web Tokens, or when I build something for myself, throw a whole bunch of invalid tokens at that endpoint to make sure it rejects all of them. Because if you use the wrong function in a library, one of these tokens with elk none is going to be accepted, and all of a sudden you have a vulnerability. You want to be the one to catch that. Because if your bug bounty hunters catch that, you have to pay them. So if you do it first, that saves you money. And of course, it also helps you to build more secure systems. That's kind of the takeaway here. But the main point that I want to talk about in this presentation is that this is ridiculously hard for developers. Why is it so hard to get this right? I honestly don't have an answer here. And there's plenty of other libraries in other languages that have similar confusions. I don't have the answer to why we are stuck in this situation, but we expect developers to know all of these details and then not use one function but the other. I don't think that's a good approach. My advice to you and to anyone handling JSON Web Tokens is encapsulate that behavior. Why on earth are you writing this code in your application, and why on earth do developers have to know about that? No. Security champions, the security team, they provide developers with libraries that handle these tokens according to best practices. That library is tested, well tested, verified, code review, whatever you want, and that absolves developers of the responsibility to know all of these tiny details about getting things right. It prevents someone from making a mistake. And that's a very, very important pattern moving forward. And that's an important takeaway here. Encapsulate security behavior in libraries. Don't expect people to just know it. Don't send, that's against my own business, but don't send 50 developers to a training to learn about JOTs so they can handle JOTs safely anywhere in the application. No, take it away from them and give them something that says, here's how we handle JOTs coming from our authentication service. Just call it and it will give you the results, and you can build your application the way it's supposed to be. And this level of abstraction is really, really important, and we see that everywhere when we do security. And we see that in crypto libraries as well, where the modern libraries are taking away the dirty details. They don't want you to select algorithms, and you shouldn't, because that's a job on its own, selecting the right algorithms with the right configuration. Just call the operation that encrypts something, and we're done. So that's example number one, the impossibility of handling JSON Web Tokens securely. Well, the unlikelihood of handling them securely. Second example is from the React world. Totally different world. It's JavaScript front-end applications, and it's pretty interesting to see what's going on there. They tried and still didn't succeed. So what's going on in React? In React, small code example, you have a template where you have some HTML code and you bind data into that template. So one of my training apps is about restaurant reviews. So what we do here is we display a review. It's very sophisticated, the application, I know. So whenever you get a review like this about a restaurant with some malicious code in there, at the end, the red part, the image source, that will trigger cross-site scripting if it's rendered in an insecure way in the application. So when you execute this application, you get something like this in your browser. Also see, I'm a design expert. That's very noteworthy as well. But it's going to be rendered, and in the end, you get some HTML in that data. Because React by default says like, yeah, I know what you're going to do. I know you're going to bind data in an HTML template, and we know that leads to cross-site scripting. So no, I'm not doing that. I'm going to escape that data in a way that when it's rendered, it doesn't trigger the execution of code. That's a big step forward, because traditionally, if you throw this in a jQuery, it's like, bam, you have code execution. You have to be very careful to handle this correctly in your applications. And with React and Angular and Ember and all of those frameworks, by definition, the modern frameworks, they handle that for you. And that's absolutely awesome. But sometimes you want HTML in the output. That's why front ends are so fun, because it's not always a very simple, straightforward case. No, sometimes you want to render something like this. Well, actually, your boss wants to you to do that because the customer asks for that, and that's how we want to render HTML. This is from CK Editor, like an online editor which you can use to format text, and in the end, it's going to spit out HTML with headers and paragraphs and images and block quotes and so on and so on. How do you render that in a React application? Well, not by using the curly braces and data binding, because it's going to be escaped. It's going to look like crap. But React has a second way to output data into the application, and that way is called dangerously set inner HTML. It's dangerous, in case you're wondering. When you do it like this, you have a problem. So they even made it very hard to use it, just so that you would have to read documentation, by the way. So dangerously set inner HTML, which is also a mouthful, that will output HTML directly into the DOM, which is dangerous, because if we put that review from before in here, it will allow a malicious user to execute JavaScript, which means I create a review with malicious JavaScript, and all of you visit that website with that review, my code will run in your browsers. Very bad. If things like that happen, we are in massive trouble, because your front end is now insecure. This is not good. That's why they made it so hard, because you're supposed to not use this all the time. You're supposed to use this in extraordinary cases when you actually need it. And then what you're supposed to do is you're supposed to sanitize the output. So there's this library called DOM Purify, built by Mario, who's here as well, the cross-site scripting expert. And if you run this review through DOM Purify, it will parse the HTML, it understands the tree, it takes out whatever it doesn't know to be safe, and it leaves you with safe HTML. So if you output the review this way, awesome. Because now DOM Purify will be like, error on an image, like, no, out. And it will leave the rest intact, and it will render our beautiful CK editor document or our review or whatever. Awesome. The pattern here is really, really powerful, because by calling this dangerously set inner HTML, we make it very clear that this feature is dangerous. And why does that help? Auto-completion for one. Remember, developers are trying to build secure applications. In my whole career, I've only met like a few people who really didn't care at all. But most of you, or most of the developers I talk to, they really want to build secure applications. And if the IDE says dangerously set inner HTML, the developer's not going to be like, it's going to be fine. They're going to be like, why is it dangerous? Hopefully. And the same thing is if you copy-paste something from Stack Overflow, which we all do, including myself, by the way, if it says dangerously in that code snippet, you're going to watch out to see what's happening. So that's really good. Mark dangerous features as dangerous to avoid accidental misuse. But marking things as dangerous only gets you so far, right? This is probably very applicable here in Switzerland. If you put a sign up like, watch out, there's a cliff there, it's not going to help you in case you actually trip and fall down the cliff. It's going to be like, oh yeah, we told you it was dangerous. It's like, yeah, that was not very helpful when you're at the bottom of the ravine, basically. So how far does it really solve anything? Well, it can, but in React's case, I don't think it does. Because this is the documentation page for dangerously set inner HTML. The full text about that property, by the way. And it says like, yeah, this is to put data into the DOM, and this is risky because it can trigger or expose your users to cross-site scripting. And that's it. So with this documentation, we kind of expect developers to understand what this means. And trust me, you only understand what this means if you already know what this means. So a developer that has never heard of cross-site scripting in detail will have no idea what's going on here. Next, we expect them to look up how to do it correctly, because the example here is not very representative. It doesn't allow you to render HTML like the CK editor document. And then the developer has to find the right solution, understand the solution, and apply it correctly in the application. 5 things to output a simple piece of HTML. And all of these 5, in a normal development environment, to me, that's a thoughts and prayers equivalent to security. It's like fingers crossed that this works out. And in practice, it doesn't. This doesn't work. Case in point, another GitHub pull request from the Signal Messenger application this time. Secure messaging client, focused on security and privacy, and their desktop version using React had exactly this vulnerability. They misused dangerously set inner HTML because they needed HTML output, and the developer in this case did not pay attention, didn't know how to do it correctly, and made a mistake. So marking things as dangerous is useful, but it's not enough. It maybe prevents accidental misuse, but it doesn't magically enable secure scenarios, because the developer still needs to output HTML. That's a feature. That's not a one-off. That's a common feature in modern web applications. And React is like, yeah, whatever. You figure out how to do that securely. Angular, by the way, does this by default, which is a more secure setting, but still not enough because there's still vulnerabilities that you can end up with. So it's a feature. So how can we use that securely? What can we do to ensure that if our developers are outputting HTML in our applications, that they do that in a secure way? Well, you're supposed to do all of these things like pen testing or whatever, but what can really work is code scanning. There's very good tools these days, very simple tools, very free tools in most cases, that can scan your application, your React app, with a set of rules and tell you about potentially things that you shouldn't be doing, like coding things that are not necessarily security problems, but not recommended, or security issues in this case. If you run semgrep on, I ran it on one of my demo applications, and it said like, hey, you have dangerously set inner HTML here. Watch out, because it's kind of dangerous. They copy-pasted the text from the React documentation page, because it's the same sentence. Same, not very informative sentence, but still. It marks this in your application. Awesome. Because now we can use that on our application every now and then or all the time, and it says like, watch out. But if you look closely at the code example that it finds, you can see that it's still marking something as potentially dangerous, even though it's safe, because we're using DOM Purify here, right? So what's going on? Well, in this simple application, we have 3 files, 1 finding. We can see like, oh yeah, this is secure, good. But what happens if you have 45 files and 10 findings? Or 100 findings, or 200? Are you going to look at all of them to see like, oh yeah, good, 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 good. Oh, not good. No, it doesn't scale very well. So instead of doing this for legitimate features, I would recommend to replace the dangerous feature with something that you know is safe. What if we had a safe HTML component? That would be better, right? Because now safe HTML, we want an element P, and we want this HTML in that component. Done. Even the semantics are correct here. Safe HTML. And that component can be implemented like this. Again, from my demo application, this works really well. And that component is the place where you sanitize the HTML. And that component is provided by the security team. And the developer doesn't have to know about how it works. All they need to know is like, hey, if we output HTML in this app, we use this component and we're done. This helps developers work faster. They're going to love it if you offer them stuff like this and tell them like, hey, you don't have to worry about security if you use our component. They're like, oh, awesome, thank you, boom, done. That's a really powerful pattern. Encapsulate security behavior. That's a repetition of our previous takeaway. It really helps to take away responsibilities from developers and allows you to get more control over your code. And in the application from before, we still have semgrep complaining. Semgrep is like, but you have dangerously set in HTML. That's a problem. It's like, yes, we do, because that's the only way to output. Well, no, there's a lot of other crazy ways which I'm not going to tell you about because they're even less recommended, but this is the way you have to output HTML in React. But now we have one finding in our application. And what we can do now is we can actually tell semgrep in this case with a comment like, yeah, we know about this, we checked this, it's fine, just pretend it's not there. It's just between you and me, and you don't have to complain about that anymore. And if you scan the application now, you get 0 findings, which is awesome. Why is this awesome? Not because it says 0 findings, but because you're now in a state where you can use this to guarantee the security of your applications. Because if you go to the dinner tonight and you have a bit too much wine, and you have to code something tomorrow, and you forget about this, and you write dangerously set in HTML, or you copy-paste it from Stack Overflow, you drop it in the application, semgrep will be immediately like, what are you doing, man? No, no, no. We don't do that. Or if you hire a new developer, an intern, and they write insecure code, a code scanning tool will immediately flag those dangerous cases. And you can customize the message and say like, yeah, In this company, we use safe HTML instead of dangerously set inner HTML, and so on and so on. And that's what I call code hygiene. And code hygiene is so critical to improve the security of your applications because it will make everything easier. It allows you to standardize on a set of secure coding guidelines which are manageable for developers and make the rest of the process more effective. If you do this for your React frontends, all of a sudden, your pen testers are unlikely to start reporting cross-site scripting problems. So you can take that off of the list. Your code scanning tools are going to be much more effective. Less noise, hopefully more accurate results. So this is something that will really help apply security best practices at scale. Thank you very much.
Thank you. Good. We have a bit of time for questions from the audience. There is a micro in the room, and now we only need your questions. You leaving or approaching the microphone? He's leaving. Okay.
Trying to sneak out, but that failed.
Trying to sneak out at the worst moment.
Christian said up front that you were too shy to ask questions.
Yeah, didn't I? Yeah.
Prove him wrong, please.
Good. I'll give you some time to warm up. Philip, you talk to a lot of developers, and I'm not. But I've heard that it's relatively hard to get in the toolbox of developers, because that's the stuff he knows, that's the stuff he's going to repeat. That's like the best, the top 10 lists from Stack Overflow, and the patterns he's going to reuse. How can we, or how can the audience, as security auditors or officers, talk to developers in a way they understand that they need an update in their toolbox, or to introduce a standard toolbox for a given company?
Yeah, that's a really good point. And my advice would be offer them something that makes their lives easier. There's a very good blog post from Netflix about how they scaled security from a couple of weeks ago, and they had the same observation. They had like a huge checklist of things people had to do for security, and developers were like, yeah, we'll have time in a couple of weeks, maybe. And it never happened. And then they said, like, yeah, this is causing friction, and they built it into a tool that helps developers set up a new environment for an app. So they went from hours to deploy a new app to 10 minutes with the tool, and the tool integrated security from the get-go. They registered domains and all of that, and all of a sudden, developers saw it as like, hey, if we use this, we save a whole bunch of time on setting up, we save a whole bunch of time on having to deal with security, and that's the way things went forward. And that's the same thing with that, with those libraries and components. If you can help them achieve their result without having to worry about additional responsibilities, that's going to be the way forward, because that creates incentives for developers to actually start working on that. Okay, so you're not really leading a security conversation with the developers, but you're offering them something that defaults to secure. Yeah, I think that's going to be the way to enable this at scale, yes. Because you can talk to developers. If you have 5 people, it's going to work, and they're probably very motivated to get things right. But the moment you get to dozens or hundreds of developers, it becomes unmanageable to have these huge lists of things to check and do's and don'ts. And if you can take all of that away, it's going to be much easier to spot mistakes, and it's going to help your security posture. I think the same graphic example is so nice, but that resonates with my job as well. If I have 0 false positive, then that gives me a good feeling. And if I'm carrying the false positive with me, they destroy the whole experience. Yeah, absolutely. And all of those false positives make it like, there's so much noise, I'm not going to look at it anymore. Yeah, exactly. You're going to miss the. And if it's positives. 0, then you look at it when it turns 1. Yeah, exactly. Great. More questions? Have you seen that was really easy? Yeah, we have a question for Mark. Microphone, the second row, please.
Thanks a lot for an interesting talk. Just wondering, shouldn't you also call out to the devs if they're using open source software to report back those findings, so that in the end, the documentation gets better and clearer? And with this JSON Web Token example you showed up with like showing 6 different parse options, shouldn't we just call out to all the devs to report back all those findings so that in the end we get better code? Sure. I would say yes, if you can spend time on that, absolutely. But
it's a very long road if you want to start fixing all of these things. And if, let's say you want to update that library to get it better in the future, that's going to be breaking changes, because all of a sudden the other things are not going to work anymore. And I'm not the perfect expert in the whole open source ecosystem and how to deal with those things. So I'm not exactly sure how that should work, but I do see that there's a lot of friction if you try to change things, because it will cause problems for a whole bunch of people depending on those libraries and stuff like that. So yeah, from an individual company's perspective, I would say absolutely try to fix the upstream problems if you can, but my typical advice for companies is build your own abstraction around that library that's vetted by a security expert, by your security team, and that's what you use internally. And if you ever have to change that thing later, let's say for JSON Web Tokens, you want to switch to another token format or different signing algorithms, you have to update one library and nobody else has to care about that. And that would be my preferred way of handling that, because that's something you actually have under control, while third-party libraries are something you can, very difficult to control, and lots of opinions that you have to take into account and stuff like that. So,
cool. Thank you very much.
You're very welcome.
A little gift from Switzerland.
Awesome.
Take home some chocolate. Even if Belgian chocolate is very good as well, the Swiss one,
is it better?
We still think we have the edge.
Yeah. I'll get back to you on that. Thank you very much.
Very good. Thank you, Philip.